Fourth video on work. Another example. Let's say we have someone on a bicycle and this person is riding down the road happily in this direction. So he's moving to the right, he's going that way. And let's say that there is a rope that's attached to this guy's bicycle seat like that. And I am going to be over here. Here's you or me or somebody that's running, holding on to this rope, and we are pulling in the opposite direction. So the bicycle, or let's say it's a motorbike, and he's moving in this direction. So I'm pulling in the opposite direction, and what's going on here, I'm holding the rope and I am applying a force in this direction. So let's say I'm applying a force F1. This is me. This is me. I'm pulling back, trying to stop this guy on this motorbike. And he's going, because it's a motorbike, he's moving in this direction, so he is applying a force that's greater than what I'm holding back in this direction. So this is the force of the bike. Let's say this is the bike. So here is, let's say here is I am number 1 and this guy here is guy number 2. So we have force 1 and force 2. Let's put some numbers on there. Let's say force 2 equals 100 newtons, just for our example to make it easy. And I'm pulling with a force, let's say, of 10 newtons. So what do you think is going to happen? I'm pulling him 10 newtons back, trying to stop him, but he's got much more force, 100 newtons. He's still going to be moving, and he moves, for the sake of our example here, he moves from here to a new position over here. Let's say 10 meters. So his new position is going to be here, and I'm just going to draw the bike over here. This is the new position. And the question is, how much work am I going to do on the guy on this motorbike? Well, I'm applying a force that happens to be in the opposite direction of the displacement. So in other words, my force is in this direction, 10 newtons. The object though, or the motorbike, is traveling in this direction, 10 meters. So let's look at this. What is the angle between the displacement and the force that I'm applying? This angle theta here is going to be 180 degrees. Isn't it? Because they're both in line, so they're parallel, except they're going in opposite directions. Now remember that the cosine of 180 degrees is -1. So if I want to know what is the work done on the motorbike, by me, that is going to be F1, which is me, the force that I'm applying, times the displacement of the motorbike, times the cosine of the angle between the force that I apply and the displacement of the bike. And in this case, the force that I'm applying is 10 newtons. The distance that's going, the displacement magnitude, is 10 meters, and the cosine of 180 degrees, since they're opposite in direction, is -1. So in this case, the work done is going to be -100 Newton meters, which is -100 joules of work. That's the work done by me on the motorbike. Work done on the motorbike by me. Now let's look at the work done on me by the motorbike. What does that equal? Understand, I do work on the motorbike. The work that I'm doing on the motorbike is negative, as you might suspect, because the force I'm applying is not going in the same direction as the displacement of the object. So it kind of makes sense. There's negative work done on the motorbike by me. But what about the work that the motorbike is going to do on me? Well, on me is going to be the force that the motorbike is pulling on me. The motorbike's going to be pulling me with a force of 100 newtons, so that's going to be F2, times the displacement times the cosine of the angle between the two. In this case, the motorbike is applying a force of 100 newtons through a displacement of 10 meters, and the cosine of the angle between the two is going to be 1, because there's 0 degrees. In this case, F2 is going in that direction, D is going in that direction. There is theta in this case is 0 degrees because they're parallel and in the same direction. Cosine of 0 is 1. So this comes out to 1,000 Newton meters or 1,000 joules of work. Notice that the work done on me by the motorbike is positive. Why? Because the force that the motorbike is applying to me and the displacement that the motorbike pulls me through is going to be, let's see here, in the same direction. I just had a thought over here, and the reason I stopped and paused for a minute was because I wanted to make sure I didn't confuse you. We need, in order for this to be true, what I said over here, we need to assume that this force 2 of 100 newtons is actually the force that's on me. All right? So what I mean to say for this example is that this force here of 100 newtons is the force that's pulling me. I'm pulling the bike with a force of 10 newtons. The bike is pulling me with a force of 100. Otherwise, if that weren't the case, we'd have to find out what the force that the bike was pulling on me was. All right, and it might be the difference between these two, 100 minus the 10. So this is not net force in this direction. This is the force that the bike is pulling me with. All right, then we could say the bike is pulling on me 100 newtons. I'm pulling on the bike with 10 newtons. All right, and then this works out fine just for the example that I gave.